Double minimal structures. Well, in this video we analyze the notion of double minimal structure or double minimal space that was introduced and studied by Abdulsada in his seminal paper on the topic. Of course, we mention several other papers in our bibliography. As for the notion of double sets, in fact, the author means intuitionistic sets here. So the ordered pairs of classical sets of the form that we have two classical subsets, namely A truth and A falsity, such that their intersection is empty. Sometimes people say that these are intuitionistic sets, while double sets are based on the assumption that we have something like A necessity contained in A possibility. Both these approaches are isomorphic in fact. However, their meaning, their semantics is different. Here we mean intuitionistic sets, but the author prefers to call them double. We assume that you are already familiar with basics of intuitionistic sets, so you know that these are our definitions of union and intersection. For example, in case of intersection, we intersect truth parts and we sum up falsity parts. Moreover, this is complement. We just reverse the order of our sets. These are intuitionistic, so double in this sense, counterparts of classical universe and empty set. And this is the idea of inclusion. Okay? As you know, intuitionistic sets are not necessarily Boolean. Their algebra is not necessarily Boolean with the operations defined above, because both the law of excluded middle and the law of non-contradiction may not be true in this framework. And Abdulsada defines a double minimal structure on a non-empty set X as a collection MDX, minimal double on X, of double sets such that the whole universe in double sense and the empty sets, they both belong to our structure. No other requirements are obligatory here. Of course, the elements of such structures are called open and their complements are closed. Clearly, this is modeled after minimal structures introduced by Popper and Noyry in classical setting. As for the interior and closure, they are also defined in a standard manner. Closure is the intersection of all those sets, of all supersets of A that are closed, and interior is the union of all open sets that are contained in A. Some basic properties. They are just like in classical minimal structures, but nevertheless, sometimes they are weaker than in, let's say, topological spaces. For example, take point 2. If, especially this, if our set belongs to this distinguished minimal structure, then it's identical with its interior, but the converse is not necessarily true. Of course, A is always contained in its closure and interior is contained in A. Moreover, we have idempotence of both closure and interior. The author introduces the following definition. A double minimal structure on X has a property BD if the union of any family of double sets belonging to the structure belongs to the structure too. So it's just closure under arbitrary unions. And if we have this closure, then the converse of the property mentioned earlier becomes true. If something is identical with its interior, then it belongs to our structure. In fact, if this property is satisfied, then we can say that we are working with double supra-topological spaces, of course. But BD is not strong enough to force the following law, that the interior of intersection of two sets is like intersection of interiors. Our structure will satisfy this law if it satisfies another property, namely closure under finite intersections. This is just like in classical setting. And just as in classical and intuitionistic topologies, we have several special cases of subsets, classes of subsets, like regular sets. Regular sets are identical with closures of their interiors, as it's written here. And the family of all regular sets is denoted in this way, of course with respect to our minimal structure. Moreover, we have several other classes that are listed here. For example, take T sets, such that interior of closure is like interior. Or take H sets, interior of closure of interior is like interior. Or C sets, they are of the form M intersected with N, where M is open and N is H set. Okay? Of course, these classes are known from classical and non-classical topologies and generalized topologies, of course. The author proves several theorems, several properties, like for example, if our double minimal structure satisfies ID property, that is closure under finite intersections, then T sets, then the intersection of two T sets, it should be A and B here, is a T set again in X. So T sets under this property are closed under intersections, finite intersections too. Moreover, under this property, the same holds for two H sets. But the family of these sets is not necessarily closed under unions. There's a counterexample in the original paper, so you should check. Another interesting property, if we have T set and it's contained in some B, but B is contained in the closure of A, then B is T2. Okay? So something like closure under supersets, but this is limited, this is bounded by the closure of A. Other relationships are proved in the paper. You should check them, you should check proofs and counterexamples. For example, the class of open sets is contained in the class of A sets. And a closed set is T set too. The class of H sets is contained in the class of C sets. For example, if we have C sets here, they are just like intersection of some open set and H set, but we can assume that M is just the whole universe. So of course then it becomes trivial that each H set can be presented as X intersected with itself, with H set as such. So some of these properties are trivial, some not. Basically, well, what's the problem with the paper? As we wrote here, it would be good to show which of the theorems proved by the author are specific exactly for double minimal structures. So first, which of these results are weaker or stronger than in case of intuitionistic topologies or double topologies, and in which cases, if any, we use the fact that the structures are based on non-classical environment, that they are De Morgan, their algebra is De Morgan and not necessarily Boolean. Okay, so both aspects, generalization and non-classicity, they should be pointed out, they should be underlined, but they are not, unfortunately. Be as it may, this is the paper that we reviewed here, Some Properties of Double Minimal Space, published in 2020. And these are seminal papers on intuitionistic sets, and this one is very important, presented in Annals of Fuzzy Mathematics and Informatics. And these are some papers on minimal structures. Thank you for your attention. Goodbye.